Hello everyone. In this video clip today I'm going to go over 3 sections of our study for this week. We're going to start with 3.6 and then I'll be talking about 3.7 and 3.8. Let's start with 3.6. It's about the derivative of logarithmic functions. Okay, logarithmic functions. Okay, so pretty much the strategy for this section, I'm going to give you the formulas and then I'll give you examples and you see how it goes. Alright, and the proof of the formula is using the definition. So we're going to skip that, but let me just recall the definition of derivative. F prime of x is limit what? Fx plus h minus f of x over h when h approaches 0. Okay, this is the definition. Whenever you guys want to prove any derivative formula, you're going to go back to the definition. Let me just give you the formula. So in this section, we talk about the derivative for the log. So if the function f of x equal to ln of x, I don't need the parentheses here, just ln of x is good. Okay? And derivative f prime of x is equal to 1 over x. Alright? A little bit more general. If f of x is equal to ln means log base e, okay, the natural base number e. Now we have a general base, a base a, log base a of x, and we call it a condition for the base. A need to be positive and a need to be different from 1. Alright? Then derivative f prime of x is is 1 over x times, let me write bigger, 1 over x times ln of x in the bottom. Alright? In our book they use the Leibniz notation, which is the same. Instead of write f prime of x this way, we can write this d over dx of f of x, okay, is 1 over x, the same. So I don't have to write both. Just one type of notation is good. I'm just trying to indicate here, just in case you guys read the book or read some other books and they use other type of notation, it means the same. Okay. Sometime our book use this, some other time our book use the Leibniz notation. Okay, I'll just write one. Now, let's talk about chain rule. What if you have, instead of ln of x, you got, say, f of x equal to ln of u, where u is a function of x, okay? U is a function of x. U here, I can erase that part. U here is not a variable. U here is just mean that u is like ux. It's a function of x. Okay? So let me write up here f of x equal to ln of u, then f prime of x. We have to use the chain rule because u is not a variable anymore. It's going to be what? 1 over u times u prime, where u here is as a function of x. Alright. And then I think we have another one involving absolute value. Ln of absolute value of x. Alright, instead of x, it's the same thing. Then f prime of x is still 1 over x. Okay. No more absolute value in here. Ln of absolute value of x, just in case x should be a negative number, you put absolute value. Okay. And of course, a little bit more general, f of x equal to ln of u, absolute value, where u is right here as a function of x, then f prime of x is still 1 over u. Now, don't forget to multiply by u prime. Okay. That's pretty much all the formulas. I think, let me double check on it. Make sure that we got it right. I cover all the formulas. Yes, those are all the formulas for the log functions. Okay. And in our section, I see that they define the number e this way. E is equal to the limit of 1 plus 1 over n raised to the n power n go to infinity. Okay. And is a constant. E is equal to 2.71828. So it means that you plug in a bigger number for n, the larger value for n, then this expression 1 plus 1 over n raised to n power will get closer and closer to the constant 2.71828. Okay, and that's the constant, just like pi. So let me give you a couple of examples, probably two, then I'm going to move on to the next section. And what we really need you to know is the derivative of ln is 1 over. Okay, ln of x is 1 over x, pretty much. All right, example. Use exercise in the book as example. Okay, see this. Y equal to square root of x, ln of x. Calculate y prime. Okay, I see that I actually have two functions in here, square root of x times ln of x, right? So we gotta use the product rules, and first of all we have to modify that radical. It looks like make it looks like the exponential form. No. Yep. So it's what, y equal to x to the 1/2. Yeah. Convert radical into exponential. So 1/2 times ln of x. All right. So take the derivative. Y prime. The formula product rule say what? Derivative first times the second. So 1/2 x to the negative 1/2. You see what I've done right here? Exponential form, x to the n. Derivative is n times x to the n minus 1. So x to the 1/2. Take the 1/2 outside. X to the 1/2 minus 1, which is negative 1/2, times ln of x. And then plus the derivative second part times the first. The derivative of ln is 1 over x times x to the 1/2. Okay? I use a couple of things in here. Product rules, u dot v, u times v, derivative is u prime v plus v prime u. And I use the power formula, x to the n, derivative is n times x to the n minus 1. Right? And if possible, you can go ahead and simplify. This is ln of x over 2 square root of x. I prefer the first line right here, but who knows what the book asks you. You can go another line. Plus, this is 1/2 bottom, so going to be 1/2 the bottom, so 1 over square root of x. You can even go further. ln of x plus 2 over 2 square root of x. Doesn't matter. You can stop the first line. If you have a test in class, write it on paper, get full credit, but note that for it looks nicer. Okay, that's an example. We not just go over the formula for ln for the log, but also recall or review the formulas for product rules and the power rules. Okay, look for one more example. Okay, I see this. Fraction. Let's have a chance to go over the quotient rule. Y equal to ln of x over 1 plus ln of x. Alright, so I see fraction right here. I have to use the quotient rule. U over v, derivative is what? Derivative of the top times the bottom minus derivative of the bottom times the top over the bottom square. Okay, so y prime, the derivative of the top is 1 over x times the bottom 1 plus ln of x minus the derivative of the bottom, the derivative of 1 is 0, the derivative of x is 1 over x times the top, which is ln of x, all over 1 plus ln of x, everything squared. And I think that we can simplify a little in here. Distributions 1 over x plus ln of x over x minus ln of x over x over 1 plus ln of x squared. Those two terms cancel out here. So I got 1 over x, 1 plus ln of x squared. 1 over x, and here I put the x on the bottom. Okay. Try one more. This is a good one. Try something with chain rule in it. Y is equal to ln of x. Okay. All right. It seems like we have a pretty complicated function, huh? So let's call this is like a u. Think of it. This is u equal to ln of x. So this is y equal to ln of u, right? So y prime. This is gonna be ln of u. Okay. So y prime is what? 1 over u times u prime. Okay. So if this is your u, you have to calculate the u prime. So how do you calculate u prime? It's going to be chain rule one more time. Let's call it v. And this is going to be ln of v. So u prime is ln of v prime, which is 1 over v times v prime. And you have v is equal to ln of x. So v prime is 1 over x. Okay? So y prime is 1 over u times u prime, which is 1 over v times v prime, which is 1 over u times 1 over v times 1 over x. This is 1 over u is ln of x. 1 over v is 1 over ln of x, and 1 over x is going to be your y prime. Okay? Since this is considered as a lecture, so I try to break it down step by step, but I claim that after a while you can calculate all those on top of your head, ln, right? So what? This is how I would do it. So I got y prime. ln, the derivative of ln is going to be 1 over whatever inside is going to be ln of x, and then time the derivative of this thing. The derivative of ln again is going to be 1 over whatever inside of that ln is going to be ln of x, and then time the derivative of whatever inside, which is ln of x, the derivative is 1 over x. We got the answer. Okay? But step by step will help you to get it clearer, hopefully. For those who studied this already, you can just get to the answer directly, and that's fine. Okay, that pretty much for the first section, 3.6. We cover the power rule, the product rule, the quotient rule, and the chain rule. Hopefully, practicing more exercises help you to master your skills. Let me move on to the next section, 3.7. Let me see the topic of it. 3.7 is talking about the rate of change. Application of rate of change, right? Let's recall back to our definition. Say you have a graph. You got 2 points. This is x1, y1, and this is x2, y2. And if you connect the 2 points on the graph with a straight line, we have this called the secant line. Okay? And we define the slope of secant line is what? Slope m is equal to y2 minus y1 over x2 minus x1, and we call it what? The average rate of change, right? And this is point A, this is point B. And then in the definition of the derivative, I showed you what? We fix point A, we keep moving point B closer and closer to point A. The secant line becomes the tangent line, and the slope of tangent line is going to be m is equal to what? The limit, right? Now, by the way, y2 is f of x2, and then y1 is f of x1 for function, and then x2 minus x1 when x2 get closer to x1. Okay. And we have the slope of the tangent line. This is for tangent line. And this is for secant line. Okay? In natural science, pretty much the same idea. Instead of use x and y as we usually do in mathematics, they just change a letter. So let's take a look at a couple of examples. Let's start with physics. Okay? So for physics, velocity in physics, velocity denoted by letter V is what? Changing of the distance over changing of time. Delta changing. Okay, this is like delta y over delta x. Change of y over change of x. So instead of using x and y as we usually do in math, distance is s and time is t in physics, and this called what? The average velocity. And you don't care about what happened in the middle. All you care is what? The initial value and the terminal, the final value. And, you calculate the difference of the distance over different time. You got the average velocity. Okay. And then the instant. This is the average. And then the instantaneous velocity is the limit of ds over dt, where dt approaches 0. And this is denoted by ds over dt. This way is delta s over delta t. And for those who took, I think this principle of physics or physics 1 before, this is what? D is s prime t. You see, ds over dt. The Leibniz notation in here, instantaneous change of distance over dt, I say. Instantaneous change of time, which is first derivative. Okay? And this is what I call the velocity, right? Yeah. Instantaneous velocity, right? Instantaneous velocity. Okay? Now, the second derivative, we talk about something called acceleration. Same idea, the average accelerations. Accelerations. The average one is A is equal to delta V over delta T. It's what? The average change of the velocity over change of time. The instantaneous one is the limit of it, of delta V over delta T. Let me just try slowly. Right. Delta T getting to 0, and this is dV over dt, which is V prime in terms of T, right? So what? V is S prime of variable T, the derivative of the distance, and acceleration is V prime of T, which is S double prime of T. So second derivative of the distance function, position function, gonna give you the acceleration. Acceleration is how fast the speed gonna change. Physics. Okay. Let's see if there's any other examples in physics in the book of that. I'll give you more. Density. Yeah. Density pretty much, let's use informal language because how thick the particles is concentrate in an object. So in the line, right? So how many dots are there in the line? So density is what? Denoted by rho. Okay. Let's take the letter R. Greek is change of the length. This is L. Let me use capital L. Over change of mass. I'm sorry. Of mass over change of length. Okay. What if you don't have a line? Let's think of it like a rod or something. What if you have a plate? So it has x dimension, y dimension, but no thickness, no z dimension. Then rho is gonna be change of mass over change of area. Okay. is the length. This is area. And M stands for mass. Okay. And the third case is what? Now that you got a 3D object, then rho is going to be dm over dv. Mass, V here stands for volume. Okay. How heavy is the material per unit? So one dimension, the unit is going to be length. 2 dimension is area, and 3 dimension is going to be volume. And you have density, okay? And change of mass over change of length. And this is the instantaneous change of the density. You can calculate the average one with delta. But we talk about derivative calculus, so I'll just write this way. Okay. How about, let's give you one more. How about chemistry? I don't know any example in chemistry. How about biology then? Biology. We are talking about, say, the growth rate. Okay? So what? Basically, growth rate is what? How fast the population changes. Capital P for population, delta again being changed, right? Over the time. Okay? The rate of change of population. Let me look, see if the book has it. They use notation. Oh, the book used n. The book write this way: dn over dt. Okay, same thing. P population. We just wrote that way, but n is counting the population. Okay. And this is called the average rate of change, right? The instantaneous rate of change is gonna be dp over dt, the rate of change at that moment. Consistent. Depends on the formula they gave you in biology. Whatever the formula for the population could be exponential formula, or the I forgot the name of the second one. Anyway, this is the formula. I don't bother to look for it. Okay. Economic then. We have the change of price. Now I'm going to write lower P for price, okay? Change of price, how about this? Change of price over change of the quantity and how many items you make, okay? This is the average cost. Change of costs. I'm going to use the same letter as the book. Over change of the quantity. The book used X for quantity, or the same thing, whatever. All right. That's the average cost. And this one, what? It costs you to make, for example, 500 items. Is that much? And you take the cost for making 500 items divided by 500 items. It's going to give you the average cost. You make 1,000 items, costs you $1 million. You take $1 million divided by 1,000 items. That's the average cost per item. And what if you want to calculate something called the instantaneous cost? In economic, they call it the marginal cost, I think. Marginal cost means what? The cost to make the next item. The cost to make one more item is BC, change of cost over dx, change of the quantity. And you see this one, if we take calculus for business, we have this marginal cost. Okay, I think that's pretty much it. And all I'm trying to bring up in this section is really the formula of what? Changing of y over changing of x, or changing of the function over changing the variable, and depends on the application that you have. They may use different letters, but it's not going to go outside of what we learned in mathematics. What? Derivative, the first derivative. Okay. Now let's talk about the last section. 3.8. See what it is about. Exponential growth and decay. Exponential growth and decay. Okay? So, exponential growth and decay means this. Say you have some quantity y, I'll use y in general, okay? And the rate of changes of y, the rate of changes of y is dy over dt, right? Change of y over time. Y could be anything. Y could be the population, could be your money, could be my money, could be any quantity, could be some population. And the rate of change of that quantity y is a constant. Means what? Proportional to the population of this quantity. So the rate of change of y is equal to a constant times what? Say you have $5,000 and you invest in some saving account that you 2%, 3%, that's the case. We're talking about the rate right here. Compounded continuously means what? Every moment your money is gonna be increased by that 1% or 2%. Okay? And this is the formula. The rate of change of quantity y is equal to k times y. And in general, I say k positive, but for let's go growth. And decay means what? K is gonna be a negative number. Now what? We're losing money or whatever the population that you're talking about right here. Say we just hit the jackpot, we got $1 billion, and we don't work, and we keep using say 10% of it continuously. And rate of changing is equal to negative 0.1 because using 10%, so it's decaying the quantity that we have. And this is the original formula. And let me show you how we convert it back. Well, let me just write a formula first, and I'll show you the math behind it. This is same thing as this. Y is equal to y naught times e to the k times t. T is the time. Y0 means the initial value, the original amount that you have. And you see that before I read, you see something like this. At is equal to p times e to the kt. This is the principal amount, the original amount. Okay, E is a constant already, K is the rate, and T is the time. Okay, so the question is, how do we get from here to here? The differential equation showing you that the rate of change is proportional to the value. Okay, so for now you got $1 million. It's 10% $1 million. A year later you only have $500,000, and then let's just make up numbers. Okay, and 10% of $500,000. So always go with the current value, and this is a formula that you should get. You should do whenever you see this, you think of this. Okay, rate K, and before I show you how to derive a formula, let me talk about the unit. T used to denote time, okay, and K is the rate. And make sure that it's gonna match up. It means what? If T is in terms of hours, then the rate is gonna be per hour. Okay? If T is in terms of day, then the rate gonna be per day. Gonna match up the unit before you multiply. In accounting and financing, people use what the compound interest formula. So let me just rewrite it. AT is equal to P times E to the, and you see the rate, RT, okay, RT. So the rate is annual rate, and the time in terms of year, right? Annual rate in rate per year. Go any bank, they tell you what the rate for now is the mortgage rate now is 3.375, 3.35, 4.25, whatever. This is the annual rate, and T is the time. Of course, it's the annual rate. The T unit gotta be in terms of year.